SATEL NETCO Design is a software tool for SATEL radio product network design and management. In this video, we will go through the basic use cases for the software, how to create the radio network, saving time on setting up your private radio network. After receiving the software installation package and installing the software to your PC with the received company-specific software license key, this web browser-based software can be opened by typing in OpenNetCo to your Windows search. Use Mozilla Firefox or Google Chrome web browsers. The default username and password are both admin in small letters. When opening up the software itself for the very first time, you will get to the Welcome page, where it's possible to check the online release notes, check for the software updates, open the online user guide, and open the software itself. The software will open to the user management view, where it's possible to modify the user management rights. Items can be viewed in the software center view, which can be called as a map view. By clicking an item in the map view, it is possible to enter to the sub-menus of the selected item, which are then displayed on the right side view. When a radio network is created, it is saved automatically to the software. Created networks can be viewed from the network drop-down list. As an example, this particular radio network consists of a base station directly connected to 4 radio stations. A remote radio station is used at the same time as a repeater to a remote station where direct radio link cannot be created from the base station radio. Radio links are displayed with a dotted line and Ethernet links with solid lines. A device submenus are available in the right side view as mentioned in the user management part. Main menu tools are available on the left side view. For example, adding devices to the map view. Please do note that also the user guide is available in the About section, where it's also possible to enter to the Welcome page. When logged in to the software with administration rights, it is possible to enter to the administration tools, check for the software updates, and also update the license. To start creating a new radio network, we need to go to the network part and press Create New on the left side view. We have the option of selecting the empty radio network and start creating a system network from the scratch. In these examples, we will use the ready-made network templates for IP data or for serial communication data. Let's go to the IP data with SATELLAR XT5RC radio modem model with QAM modulation with the ready started system template and press Create. After the network template has been downloaded to the view, it has been automatically saved also to the drop-down list, so now it's saved to the PC. In this view, currently we have a ready-made IP router towards the SCADA, and we have an IP switch connected with the Ethernet cable to the base station radio, and one remote station connected with the radio link, and one PLC connected with the Ethernet cable to the remote station radio. Communication method is by default in this network template proxy ARP in layer 3 communication mode, in a way that we can use IP addresses from the same subnet to all the devices in the same radio network. We can change the communication mode from the software settings, as in network settings, lower left corner, and entering to the Design Assistance, and from the LAN mode drop-down list. As mentioned, currently in use proxy ARP, we can change that, for example, to layer 3 routed mode, or selecting layer 2 communication modes as in bridge broadcast or bridge broadcast all communication modes. For this example, let's continue with the proxy ARP communication method, and in the LAN settings, it is possible for us to assign for the software what is the subnet that we are giving the device's IP addresses from. For this example, let's change the IP address subnet to 20.0/24. And as an example, let's go to the upper right corner and press Assist and run and check the IP addresses. So now in the upper right corner in the notifications, the software is indicating to us what has been done. The software checks whether the radio parameters match in a way that the communication is possible to be executed. The IP addresses are given from the subnet 20.0 to all the devices and checked that there are no duplicates. IP routes are created. Radios are given unique radio addresses, and the radio routes are created behind the scenes. If we want to see what has been created to the radios, let's click, for example, to the base station radio, sub-parameter menus, radio and central unit separately, central unit, routing, IP routing, and IP for routes. For example, in this case, for the remote station radio and remote station PLC address 20.2 and 20.4/32 addresses can be found behind the radio address number 2. So these are all created by the software automatically by pressing Assist and Run button. For this example, let's assume that the IP router towards the SCADA is having the gateway address of 254. So clicking the IP router icon, we can enter to the IP address and change that manually. By pressing enter, we add the small tick box for the log sign, which also appears to the map view, indicating to the software that this is selected by the user and the software cannot modify this IP address anymore. Let's assume that the SCADA is in another subnet, so we can add that subnet to the IP router parameters. So this is the subnet that the SCADA and the related PCs are connected to. And let's add one more station to the system network. That we can do by going to the left side view, nodes and links, add node, and from the drop-down list, let's select the corresponding radio modem model SATELLAR XT5RC QAM modulation, and let's select also connected PLC as in generic IP host and add that to the map view by clicking mouse left. The small plus sign as an indication that there is a device that we can add to the map view, which we selected, and that can be removed either by selecting the Select Any Map object from the upper left corner or by pressing the ESC button. Let's go to the nodes and links, select Add Link to add links between the generic IP host and the remote station radio 4 by clicking mouse left on top of the generic IP host and clicking mouse left on top of the radio. The radio link, as in the dotted line, can be also added by clicking mouse left on top of the selected radio. We could select the base station radio to create the direct link between these two radios, but in this case, let's use the remote station number 2 as a repeater at the same time for this new radio. Pressing escape again in order to remove the plus sign from the mouse cursor. And now, as we change the IP address of the IP router, added IP information for this device, and we also need to assign IP addresses for the new stations. Let's go to the upper right corner, press assist, and run for the software to assist us creating the IP addresses, radio addresses, recalculating the IP routing tables, and recalculating the packet routing tables as in radio routing tables. Now the IP addresses have been given to the devices, and if we are happy with those, we can track all the devices in the map view, clicking mouse right, and lock all addresses. If there is a need to modify IP addresses, we can do those manually. As an example, let's change the 20.4.5 IP address to 50. And again, when pressing enter, tick box selection has been made and the small log sign appears for this generic IP host. Let's log all the other IP addresses. But as we made already this small change to the connected PLC, let's once more press assist and run to recalculate the IP routes. Radio network critical parameters can be found from the Common Settings tab. So these are the parameters that are common for all the radios in the system network. Let's change, for example, the frequency to 443. And in this case, the local frequency authorities have given us the same frequency for the TX and RX. The modulation mode has been set to automatic, as in the radio is automatically selecting the suitable modulation for each and every radio link according to radio link health. Starting modulation is 4 QAM, which is the lowest modulation that the radio can go to, and the starting point as well. Highest modulation being the 64 QAM modulation. These parameters are all added automatically to all new nodes. Making any changes in here will automatically be created also to the map view. As an example, let's change some other parameters as well for the radios. By default, the software creates the names for the radios, which can be seen in the LCD user interface and the web user interface of the devices. By clicking the radio name, we enter directly to this parameter, which we can modify. Let's modify, pressing enter. Now this radio name has been changed to base. Radio 2 name, let's change it to remote 1. And node 4 name to remote 2. Let's check as we made changes to the Common Settings tab. Let's check that the radio communication is still suitable and all good to go. Small exclamation mark on the upper left corner of the device icon indicates that there are parameters or a parameter that we need to synchronize from the software to the device. To synchronize the parameters from the software to the device, we need to connect the PC to the powered radio device with USB-A to USB-B cable, USB-B port connected to the device USB-B. The device is fully powered and ready for synchronization when the power LEDs and stat LEDs are both lit statically. After connecting the device to the PC, we need to check from the device manager the COM port number which the Windows has recognized for the device. For the first-time users, it will take a while for the Windows to search for the suitable drivers for the connection. After the COM port is known, we have to type that information into the software settings, into the network settings, and local connection, and type it in here. After that, to start the synchronization process from the software to the device, click mouse right on top of the device in the map view and select Sync to Device. The configured COM port number can be found from the local connection. Alternatively, we can type that into the custom connection by using local and editing the string. In this example, let's use the local connection and test the connection by using the test button. COM port is available and existing. Continuing with the next, synchronization is needed as an indication with the exclamation mark on the map view. Continue with next button. The device is identified with the firmware and serial number information. Continue by pressing next. After synchronization process has been finished, the indication will appear. Total parameters written to the device, failed parameters, and detailed info available behind this small button. We can press close and continue to the next device with the synchronization need. If the tests are performed in laboratory circumstances, it is recommended to use the lowest possible TX power in the radios, have at least 50 centimeters of distance between the radios, and to use 20 to 30 decibel attenuators in the RF ports of the devices. It is possible to test the radio network from the software by using the over-the-air network connection. If you still have the PC connected to the base station radio with the USB-B cable, let's go to the network settings and type in to the over-the-air network connection parameters the same COM port number that you have currently in use for the connection. As in my case, COM port number 8. Then let's paint all the radios in the system network. Click mouse right on top of a radio and select Radio Connection Test. Over-the-air network connection with COM port number 8. Alternatively, we can select the custom connection, over-the-air network connection, and using the over-the-air network addresses as in radio addresses, and typing manually in the correct COM port number currently in use. In this example, let's use the over-the-air network connection with the COM port 8. Test the connection, COM port still available, and continue by pressing next. Now timeout for the radio ping and ping count per station. To start the connection test, press start. The RSI readings from the network station by station, as in link by link. Alternatively, if you have your PC connected directly already to the base station radio, you can start the command prompt and start pinging the stations. Let's start from the base station radio, directly connected to the PC, testing the connection to the remote number 1, as in 20.2 IP address, and the same way to the 20.3 IP address through the remote/repeater station. Now, as we know that we have the IP connection from our PC to the radio network, we can also use the LAN connection to synchronize and for the radio connection tests as well. So for the radio connection test, the similar type, radio connection test, and we can use custom over-the-air network connection, but now with LAN IP selection. The LAN IP in the radio connection test, the first connection point is the base station radio 20.1 in our case. So this would be the setup for the radio connection test via the LAN interface. For the over-the-air network synchronization, let's change, for example, the remote 1 radio station name to something else. And thus we can see the exclamation mark again as an indication for this unit that there is a parameter that we need to synchronize from the software to the radio. So we are connected with our PC to the base station radio at the SCADA end. So over the air connection, clicking Sync to Device. And let's use the over-the-air network connection and using the radio addressing. Let's test the connection first and continue with the synchronization process. The same way as before, the radios are recognized by the software, by the serial number and firmware version information, but also with the CRC checksum of the current parameters. If no parameters are changed since last synchronization, the optimized synchronization method will be used, and only the parameters that we are about to change right now are sent over the radio interface to the device. The same type of a synchronization done indication text appears as we did have with the local connection. Total synchronized parameters, failed parameters, and detailed information available. And now, as fully synchronized, the device has green tick mark again in the device indication. Now, as our radio network is complete and automatically saved to the network drop-down list, as a backup file, let's go to the network part and export the parameters as in full configuration file as a separate file to our PC as a backup file. Pressing export, selecting the optimized mode as in all parameters that are changed from the factory settings are gathered to this file. To include also all confidential data, such like the AES encryption keys, to this file, please select the Include Confidential Data tick box into use. Pressing Next, and now the file can be saved to the PC. By default, the software creates the radio and IP routing tables from the root node towards the remote radio stations, and for the remote radio stations the communication paths are created only towards the root node. If there is a need for the remote station devices to exchange IP data with each other in the selected Layer 3 communication modes, user needs to enter to the network settings, to design assistance, and change the radio routing and IP routing creation rules from the currently selected tree mode into all in both of these selections. Now, as assist and run is applied in the software, the radio and IP routes are created from all devices to all devices. To start creating a serial communication data radio network with message routing functionality, we need to enter to the network on the left side view and press Create New in order to enter to the ready-made templates. From here, we can select the serial data with message routing functionality with SATEL-EASy Plus radio modem models and press Create. Message routing is intended for serial communication protocols such like Modbus RTU or IEC 101, where the data communication is polling type and the data is gathered from remotes to single location. Base station radio, as in root node, reads the terminal address from the incoming data and sends the data to the defined radio address according to the terminal address. Remote radio stations send the data from the connected devices to the base station radio serial port. SCADA Control Center icon indicates the currently in use protocol, which can be changed by clicking to the SCADA icon and selecting protocol from the list. Currently set parameters are typically used, example with Modbus RTU protocol. Solid line indicates the terminal connection between the devices. Base station radio, which is indicated with the root node text, and radio links are indicated with dotted lines, and the remote terminal units with its own icon. The remote terminal unit address can be seen also in the map view. Radio network critical parameters, as in common settings, can be found from Common Settings tab, where the radio critical parameters can be modified. These are all common parameters for the radios in the same radio network. By default, these parameters are also set to new nodes created to the map view. As an example to this radio network, let's add one more radio. Let's go to the Nodes and Links, Add Node, and from the drop-down list, let's select the suitable radio modem model into use. Small plus sign on the mouse cursor icon indicates that we can add radios to the map view by clicking mouse left. Now let's go back to the Add Node, and from the drop-down list, let's select Generic Serial RTU and add that to the map view. After that, we can add link, as in RTU connected to the remote station radio, and the remote station radio, let's connect that in this example to the remote station 2, which is also used as a repeater at the same time. Pressing Escape in order to remove the plus sign from the mouse cursor. The terminal address for the serial RTU can be added to the device by clicking the device icon on the map view and entering to the terminal address tab. Unique terminal addresses has to be defined by the user. The input format is in decimal. As for this example, let's imagine that there is an RS-485 connection in this remote radio connected to multiple terminal devices. Let's add 2 terminal addresses for this particular station. And in order to create the unique radio address, let's go to the assist and run. In order for the software to create the necessary unique radio addresses, calculate the radio routing tables, and check whether the radio network is possible to be executed with these radio parameters. In order to modify the radio parameters, such like serial port settings, let's take the radio icon on the map view and enter to the specific radio parameters on the right side view. Same way we can configure, for example, the remote radio 2, port 1 settings data, RS-232. Let's select the port speed and even parity. These parameters can be sent to all other radios as well by clicking these green 3 lines on the right side and selecting Set to All Compatible. As in, sent to all radios in the same system network. So by clicking the base station radio, we can see that these same parameters are used in the base station radio as well. After all modifications done to the map view, we can always check whether the parameters can be used in the system network successfully by clicking Assist and Run. Radio routes calculated, all parameters can be used as in green text in the notifications. And now the parameters can be imported into the radios. In order to send the configuration from the software to the device, we need to have the hardware connection to a powered radio. The programming mode switch in the adapter can be used to force the radio serial port parameters into unknown state. The currently in use COM port parameters can be configured to the software in the network settings and selecting local connection. Now, as clicking the mouse right on top of the map view radio icon, we can select Sync to Device. The defined connection parameters can be found from the local connection selection. Testing the connection with Test button, the COM port is available. Continuing to the synchronization process by pressing Next. Radio has been recognized with the firmware versions and the serial number information. The synchronization process is started. After the device has been synchronized fully with all the parameters found in the software, synchronization done icon appears. In total parameters configured to the device, failed parameters, and detailed information can be found from this small icon. Pressing close, and the radio icon indicates that all parameters are matching between the radio and the software configuration file. Continuing to the next radio. After all the devices have been synchronized with the parameters from the software to the devices, the system network can be tested with the radio connection test. Please do note that for the radio connection test, the programming mode switch has to be set to off state. To check the radio connection availability, paint all the radios that the radio connection test has to be performed to, click mouse right on top of a radio and select Radio Connection Test. Please do note that you have to be connected to the base station radio, programming mode switch set to off mode, and the serial port parameters have to be configured according to the set base station radio parameters. In our case, let's use in this example custom connection, local connection, and configure the COM port parameters according to set in the PC. The baud rate in our case at the base station was RS-232 with 19.2 kilobits per second. Testing the connection with test button, the COM port is available. Continuing with the next button. The test timeout per ping is 4 seconds by default. The ping count by default is 3 times per device. Starting the test with start button. Radio connection test performed. RSSI values are displayed, and those values can be also saved to a separate file. The created system network can be saved to a separate file by selecting Network and Export. From this selection, let's include also the confidential data, meaning that, for example, the created encryption keys are included in this separate file. Pressing Next. Now the file is ready to be saved to secure location. The saved file can be also imported back into the view by selecting Import and browsing the file from the saved location. To start creating a serial communication data radio network with NMS routing functionality, we need to enter to the network, press Create New, and from the ready-made network templates, select the serial data with NMS routing with SATEL-EASy Plus radio modem model. Press Create. NMS routing is intended for serial communication protocols such like Modbus RTU or IEC 101, where the data communication is polling type and the data is gathered from remotes to single location. Base station, as in root node, reads the terminal address from the incoming data flow and sends the data to the defined radio address. Remote radio station sends the data from the connected devices to the base station radio serial port. NMS stands for Network Management System, meaning that it is possible to monitor the radio network online when the system data flow is present in the radio network. As the SATEL NETCO design is for network design, configuration and management, the monitoring can be done with a separate software tool, SATEL NETCO NMS. SCADA Control Center icon indicates the currently in use protocol, which can be changed by clicking the SCADA icon and selecting the protocol from the drop-down list. The default being Modbus RTU. Solid line indicates the terminal connection between the devices. Base station radio is indicated with root node text. Radio links are indicated with dotted line. Remote terminal units are indicated with their own icon. The remote terminal unit terminal address can be also seen in this map view. Common Settings tab, where all the radio critical parameters can be modified. By default, these parameters are also applied to the new nodes created to the map view. Now, as an example, let's add one more radio station into the map view by selecting Nodes and Links, and from the Add Node drop-down list, selecting the suitable radio modem model. The small plus sign on the mouse cursor indicates that whenever we click mouse left on top of the map view, a radio is added. Let's add also connected device by entering to the Add node and selecting generic serial RTU. Let's add link by selecting Add link and clicking mouse left on top of the generic serial RTU and connecting that to the remote radio station. Adding radio link by clicking radio, and in this case let's add the link to the remote radio number 2, acting as a repeater station at the same time. Pressing escape in order to remove the small plus sign from the mouse cursor. The RTU addresses can be modified manually by the user by clicking to the serial RTU icon in the map view and modifying the existing terminal address. In this case, let's use an example RS-485 connection to multiple RTUs at this remote station and add multiple addresses into use. Radio parameters such like serial interface settings can be found from the radio subsettings, serial interface, port 1 and port 2 settings separately. As an example, let's configure the radio 2 with 19.2 kilobits per second, 8 even parity and 1 stop bit. These parameters can be set to all radios in the map view by selecting the green 3 lines on the right side and selecting Set to all compatible. These parameters are also taken into use in the base station radio. To calculate the necessary radio routing tables for the base station radio and for the terminal addresses, let's use the assist and run to create the necessary unique radio addresses, calculate the radio routing tables according to the set terminal addresses, and check whether the radio communication is possible with the created radio parameters. As all notification texts are indicated with green, radio routes are created, no errors in the system, and thus the synchronization process from the software to the radio can be started. As all the device icons are currently indicated with exclamation marks, there is a need to synchronize the parameters locally for each radio separately. For sending the configuration from the software to the device, we need to have a device connection to the powered radio. We can use the programming mode adapter with the programming switch, and when the programming switch is enabled, radio parameters are temporarily forced into known state. If you have the NMS cable, you can use the NMS branch in order to send the configuration from the software to the device. Currently in use COM port settings can be configured to the software from the network settings and local connection. To start the synchronization process, on the map view, click mouse right on top of the selected device and select Sync to device. The local connection parameters can be found from the local connection selection. Testing the connection to the COM port with test button. COM port exists and is available. Continuing to the synchronization process with next. Synchronization needed. Continuing with next. Device recognized with firmware and serial number information, starting the synchronization process. After the successful synchronization process, total configured parameters, failed parameters, and details are available. Continuing to the next device. After all the devices have been configured, as an indication of the green tick mark on the radio icons, the configuration file can be saved into a separate file from the network and by selecting Export. In this selection, let's include also the confidential data in order to include also the connection strings into the file. Pressing Next, and the file is ready to be saved to secure location. A radio connection offline test can be done between the radios by selecting all the radios, clicking mouse right on top of a radio, and selecting Radio Connection Test. Please do note that the radio connection test in NMS routed mode can be executed only by using the NMS connection method to the base station radio. Over-the-air network connection is required for the NMS routing regime. In this case, let's use the custom connection with over-the-air network connection with the selected COM port number and the NMS port baud rate. Testing the COM port availability and continuing to the tests with next. By default, ping timeout 4 seconds, ping count per station 3, starting the ping. The link RSSI values are displayed in the view and also can be saved into a separate file. With NMS routing, it is also possible to modify the remote radio parameters. Let's change, for example, the transmission power of the remote radio, something else as an indication of the exclamation mark again, and start the synchronization process from our PC through the base station radio to the remote radio by clicking mouse right on top of the radio, selecting Sync to device, and by using the over-the-air network connection with the NMS port. The device is identified, and if all other parameters are matching to the previous set, the optimized mode can be used, continuing with next, and thus only the changed parameter is set to the remote radio. After the synchronization process has been done, totally changed parameters, failed, and detailed information available. For more detailed information, please see the user guide. For any additional information, please contact SATEL.